Hello and welcome to the third installment of the ExamRiz live GCSE maths sessions. Thank you very much for joining us. Today we've got a whole host of topics, really complex topics today we're going to be tackling. So I'm very pleased that you're here to join us. We're going to start with vectors. We actually finished off the last section of those of you who were here with us last week. The last thing we did last time was the beginnings of vectors. We're going to get into the more complex stuff now. And for those who maybe missed last week's session or just need a little bit of a recap, I'm going to go through just some of the important basics of vectors before we get into the really complex stuff. So if we take a look at this diagram that's on the screen right now, first thing I'm going to do is actually just ignore the question that's written there. Just talk about how vectors work. So vector is basically like, how do you get from one point to another point using only lines with arrows on? So for example, here we can get from point O to point A using vector A. We can get from point O to point B using vector B, because both of those lines have an arrow on them that is called A and B respectively. Now, if we want to get from A to B, we cannot use this line that goes straight down there. The reason why is because there is no arrow on that line. It's almost like a forbidden line. We can only use lines with arrows on. But the solution is quite simple, because we can get from A to B by going backwards this way and then forwards that way. So that vector, which we would notate as AB with an arrow, capital AB with the arrow on top, signifying from A to B, would be written as negative A plus B, because negative A because we're going against the arrow on that line, and positive B and plus B because we're going with the arrow, so it's a positive B. And these are lowercase because they are the vectors as opposed to the points which we are going to and from. So that's the basics of vectors. That's kind of the most important part you need to know. I'll just erase all of this and then we can get into the question they're actually asking on this one. So vectors in the form that I just spoke about is probably like a grade 5 or 6 level question. These type of questions are now the grade 9 questions. Now, let's be straight. When it comes to grade 8 and 9, majority of people are not going to get those grades. That doesn't mean you can't aim for them, and that certainly doesn't mean you can't get some marks on those questions. And that's what's really important. Those sort of final 5 or 6 questions in your GCSE paper, a lot of people look at them and say, I don't know anything. I don't get any marks in those questions. Believe me, you're not alone. It happens to so many people. But because it happens to so many people, if you can be one of those who can just pick up 1 or 2 marks on each of them, that will set you so far above everyone else that could actually be a game changer in terms of the grade you get. So don't look at those final 5 or 6 questions as, I don't know them, I can't do them. Look at them as, this is my opportunity to get those 1 or 2 extra marks on each of them to take me above a huge chunk of everyone else. So I'm going to show you how to do that. Even if you can't do this question entirely from beginning to end, don't worry. I'm going to show you how you can get your first mark, which may lead to your second mark, which may lead to the third, fourth, fifth, etc. So they're telling us here, they are defining O to A, and you see we've got this capital letters with an arrow that's signifying to get from O to A is A, which is, we can see signified on the graph there. O to B is B. P is the point on AB such that AP to PB equals 1 to 3. Whoa, what the hell does that mean? That is a lot of information, and again, majority of people ain't gonna have a fucking clue what that means. So let's break it down. P is a point, so it's not been drawn on there. P is a point on AB. AB is this line, the line literally going from A to B, such that AP to PB is 1 to 3. That means AP, wherever P may be, AP is worth 1 and PB is worth 3. So the distance from P to B is 3 times bigger from A to P, which means P is going to be around about, I'd say, here, because this distance from there to there is essentially a value of 1, whereas this distance from here to here has a value of 3. It's 3 times bigger, which means that AP is a quarter of the distance and PB is 3/4 of the distance. So a lot of time people can look at a ratio 1 to 3 and think, oh, a third. But actually, no, 1 to 3 means 1 part over here, 3 parts over here, 4 parts in total. So Yeah, A to P is a quarter of AB, and P to B is 3/4 of AB. Now, it's a really important thing to sort of get your head around, and we're going to keep coming back to it. So don't worry if you don't understand it. But if you do understand it, please let me know. And if you don't, please leave a comment as well. If you have any questions or comments you'd like to put, constructive or even non-constructive, that's fine. Just engage in the discussion, and I'll try my best to reply. Although sometimes you're going to get ignored. I'm sorry. It's just the way it goes. Anyway, let's move on with this question. They're now saying O to P equals K brackets 3A plus B. Find the value of K. So my general rule with vectors is on any question, if they have mentioned a vector, find the vector, even if they're not asking you to find it. If they have mentioned a vector anywhere in the question, just find it. Now, they've mentioned OA, but they've told us what it is. They've mentioned OB, and they've told us what that is. They've mentioned OP, so our aim right now is quite simply just going to be, let's find OP. Now, OP should be the straight line that goes from O to P. However, as we've learned already, when we're dealing with vectors, we can only use lines with arrows on them. So that line from O to P is actually completely pointless. We want to get rid of that. That does not help us. We can only use lines with arrows on them. So the first thing I like to do with this is define our journey of how we're getting from O to P. So the way I would write this is OP equals OA plus AP. That's because we're going to go from O to A up there, and then we're going to go from A to P that way. That's our journey that we're going to go on. We could quite easily go from O to B, then B to P. Absolutely, if that's what you want to do. But I want to do it my way, all right? So that's what we're going to do. So as we start defining this journey, we can start figuring out the vectors involved in that journey. So first of all, O to A, we already know that's A. They told us that in the question. They were very, very kind about that. Next up, AP. Now, if you were with us at the end of last week's lesson, you remember me saying this, but I'm going to recap it in full just in case you weren't there or in case you don't remember. When you're trying to find a vector that is part of the way down a line, don't do it. Find the entire line that it's on, then find the fraction that you want of it. So for example, AP is on the line AB. It's part of the line AB. So what we're going to do is we're going to find the whole of AB and then figure out how much of that we want. And we've already notated that AP is 1/4 of AB. So we can literally just write that directly below AP. AP is 1/4 of AB. Now on our next line, we can input that vector. So this is just going to be the same A from above plus 1/4. And then what is AB? Well, we spoke about it earlier. It is going to be minus A plus B. Minus A plus B. Then we can expand that bracket and collect like terms. At this point, it's no longer really a vectors question. It's just an algebra question. So this is going to be A, actually minus, because 1/4 times minus A is going to be minus 1/4 A plus 1/4 B. And we've got A minus 1/4 A, so that's going to give us, and I will scroll down here a little bit. That's going to give us 3/4 A plus 1/4 B. So that is the vector OP. However, we're not done just yet. We need to remember what this question is asking us to find, because at the end of the day, it wasn't asking us to find OP. It just mentioned OP, and that was my idea to say, let's just fucking find it. OP equals K brackets 3A plus B. What they're trying to say is OP, as we have it, needs to be expressed as something factorized out of 3A plus B. Now, the thing that gives me confidence in this is the fact that when we look at our A and B value in our answer in here, we have a 3/4 A and a 1/4 B, which goes along with the 3A plus 1B. We obviously don't write the 1 in those situations because we just don't need to. And then it kind of comes just down to how good are you at factorizing? Quite simply, we're just going to factorize out 1/4. So if that's something you can spot really easily, congratulations. If not, maybe start revisiting some factorization. This is a complex factorization for sure, but Hopefully you can see how it works by me just writing it, because this quarter gets taken out. And sometimes you have to imagine, well, if I times it back in, what would it be? A quarter times 3 is 3/4, and a quarter times b will be a quarter b. So you can see how we get that answer. But again, much like with a lot of the topics within vectors, and actually within any topic, we're going to be revisiting this because we're going to be repeating. Repetition is the key to maths, and maybe other subjects, I don't fucking know. I'm a math specialist, but repetition is the key to maths. Unfortunately, it's also some of the boring stuff as well. Okay, that's that question. So K is a quarter. That's it. Done. Now, that is a 4-mark question, apparently. I would like to think that you can get... Let's try and break down where the marks actually come from. Because majority of people, like I said, will not get all 4 marks on this. But if you can get 1 or even 2, that would be great. So, starting to notate OP, from O to P, also pointing out where P is. So just pay special attention to the ratio that they show in the question. AP to PB is 1 to 3. That means this first section of AP is worth 1. The second section of PB is worth 3. So 1 in terms of length, 1 part, 3 parts. So it's a 1 to 3 ratio. 1/4, 3/4 makes the whole. I'm certain our next question we will get to practice this a bit more. Okay, question 2. Nice comment there from AMT 2023. Only got a few more days until 2024. But thank you very much for your comment. How are you? I'm fine. Thank you for wishing me well. I hope you're well too. And you enjoy watching my TikTok. I enjoy watching my TikToks as well. We've got that in common. So that's great. Fantastic teacher. Thank you very much. And if you're a maths tutor, excellent. I fully support that. We need more people spreading the good word of maths. Keep it up. Okay, this question is going to be very quite similar in how we approach it. The tablet's just crashed a little bit. I'm sure we'll be back up and running in a sec. There we go. So OA equals 2A, as we can clearly see. OB equals 3B, as they've kindly drawn on there. P is the point on AB, such that AP to PB is 3 to 2. Okay, so this gives us another really good opportunity to figure out how this ratio actually impacts the diagram. So have a read of it. Before I say anything, let's take a few seconds to have a look at it and see if you can picture on this diagram where that point P is going to go. I'm going to draw it in afterwards, and if you got it right, congratulations. You can let me know if you want, or you can just keep it to yourself as just solid pride, humble pride. So point P is on AB, so it's on this line. AP to PB is 3 to 2. Aroa Rubio Perez, you don't get this. Don't worry. Most people don't. If I'm being perfectly honest, most people don't understand this. But we're going to try and help you get at least the first couple of marks. So let's pay real close attention to this first bit, because if we can get this first mark, it will unlock the next bit. So AP to PB is 3 to 2. So there's going to be a point somewhere along this line where it's split into 3 parts and 2 parts. That means it's going to be over halfway, right? Because if this is 3 parts, maybe it's there, and then that is 2 parts down there. So P would be there, with this section being 3/5, and this section down here being 2/5. And that is in terms of the length of the entirety of the line. So hopefully we've been able to get our head around that first aspect. Next is it's saying OP equals K brackets 4A plus 9B. Find the value of K. So once again, just because they have mentioned OP, we are going to find OP. And that means, how do we get from point O to point P using only lines with arrows on them? So first of all, let's notate our journey here. OP is going to be O to A, taking us up there, plus A to P, taking us down there. Now OA we already know is 2A. And AP, as we have learnt, if we are finding the section part of the way down a line, we find the entire line and then say what fraction we want. So AP is going to be 3/5 of AB. And I'll recap that. So AP from this point to this point is 3/5 of the entire line. So we're going to stick with 2A just from above plus 3/5 of, and remember AB is how do we get from point A to point B, and that means I'm gonna just erase some of this stuff because it's getting a bit messy. And how we get from A to B, we would go back this way, then up that way. Aisha, Mila, can you go the opposite way? Yes, you absolutely can. I just chose to go this way. You definitely can go from OB to BP, not a problem whatsoever. I just prefer going this way because it's easier sort of going up and then down rather than across and then sort of backwards up, just visually. It's no more difficult in the actual question. Just for me visually, it's like climbing up the slide and then going down it as opposed to walking alongside the slide and then climbing up it. But that's just a personal thing. So AB is going to be minus 2A, because remember, you're going against the arrow. We're going backwards, plus the 3B. And we're going to expand that and simplify. So the 2A is going to remain, of course. And now this bit we've got to be really careful about. A lot of people struggle when it comes to timesing fractions with numbers. But if you have a number multiplying a fraction, you just times the number to the top of the fraction. Because this -2 is the same as just -2/1. We just don't ever write the over 1. So this is going to give minus 6/5 of A, because 3 times -2 is -6. So 3/5 times -2 is -6/5. Plus 9/5B. Once again, because 3/5 times 3, we times the integer value of 3 on the top of the fraction to create 9/5. And now we're going to do 2A minus 6/5A. If you're lucky enough to get this question in a calculator paper, then you can just quite easily type into your calculator 2, take away 6/5, and you'll get a nice answer. But if not, you may have to just go to the side a little bit and do some sums with fractions and write it as 2/1 minus 6/5. Either way, you're going to end up with 4/5 A plus 9/5 B. And then if we look at what the answer is supposed to be, they're saying up here, show that OP is K brackets 4A plus 9B. We've got the 4, we've got the 9, that's great. What they both have is an over 5. So that kind of gives us the hint that if we just take out 1/5, that's going to leave us with the 4A plus 9B. Okay. How are we feeling with that? Got a lot of comments of, unfortunately, a language I don't understand, so I do apologize about that. Let's crack on with this next one. I'm going to go through this one slightly quicker because it is the same thing, but hopefully it'll sort of just consolidate the structure, and I'll show you sort of how we go through it when we're at optimum levels. So P is the point on AB such that AP to PB is 3/2. So that's going to be 3/5 of the way. If you want, you can, just from the very beginning, you can look at that ratio as 5 parts and write it as 3/5 to 2/5. That might help. And then you know it's going to be, AP is going to be 3/5 of the way down. So once again, P looks like it's going to be down there. 3/5, 2/5. OP, once again, so we're going to define OP as going, I'll tell you what, let's do it the other way around. Just for you, Aisha, let's go the other way around, just to show how it's done. OP, we can do OB plus BP. Now, OB is going to be 2B, just simply because of that line there. And then BP. So this is where it gets interesting. BP is going to be 2/5 of BA. Now, direction is incredibly important here. If we're going from B to P, that is 2/5, not of AB, because AB is going from A to B, but BA. Direction is so important in vectors. If you were here with us last week, you would have heard my anecdote about Despicable Me and the bad guy called Vector, because he has magnitude and direction. And it's just a great line from a great film. I wrote 2/5 BP. Of course, I mean BA. I was just checking to see if you were all awake there, because I am, just about. 2B plus 2/5 of, and what is BA? How do we get from B to A? We go minus 2B plus A. Minus 2B plus A. So that equals 2B plus, now just again, practice of timesing numbers by fractions. The number times is to the top of the fraction, not to the bottom. That's only when we're doing fractions times fractions. We do top times top, bottom times bottom. So that's actually going to be negative, isn't it? Minus 4/5 B plus 2/5 A. And once again, you may have to do a little bit of fraction work here to do 2 take away 4/5, but that is going to leave you with 6/5 of B. And I'm going to scroll down so you can actually see it. 6/5 of B plus 2/5 of A. And now we're going to have to factorize because we want K brackets A plus 3B. Now, both these things are over a 5, so we're definitely going to take over 5. But actually, in this particular case, we're going to take 2 over 5 out. One of the ways we can look at that is because they want the A to be just a singular A, and we have 2/5 of A. So if we just take the entire 2/5 out of the situation, we will be left with just a singular A. So that's also another way we can try and figure out what we're going to factorize. If we want the A by itself, it's got 2/5, get rid of 2/5. So 2/5 bracket, and we'll write the A first because that's what they've got in their answer. So the A plus, and then we'll be left with 3B here, simply because 2/5 times 3 is 6/5. 2 times 3 is 6, so 2/5 times 3 is 6/5. Okay, very good. This question is horrible. This question is such a horrible, horrible question that I even considered not doing it, not even going over it because it was so mean. However, for those of us who really want to nail these and get the highest grades, I'm going to go through it because, well, you're never going to get 100% if you don't know how to do 100% of the content. So let's strap in. For those of you who already think this isn't for me, don't worry about it. Try and follow for as long as you can. Try and get maybe the first 1 or 2 marks. And if it gets too much for you, just sit back and relax. Don't stress about it. I'd say 99% of people aren't going to get this question right in the exam. So, it starts by defining the vectors that are already drawn on there, which is very nice. M is the midpoint of BC, as we can see there. By midpoint, that's telling us that it's half of the way. So if we want to get from B to M, it's going to be half of BC. X is the point on AB extended such that AB to BX is 3 to 2. Whoa, okay, that again is a lot of information. X is the point on AB, so this is line AB, extended. So AB extended means it goes out here, such that AB to BX is 3 to 2. So the distance from A to B is worth 3, so the distance from B to X is worth 2. So X will probably be around about there, maybe a little bit to the left. Maybe I've overshot that a little bit, but it doesn't matter too much. So this is going to be, yeah, that's sort of 3 parts and that's 2 parts. Prove that E, M, and X are on the same straight line. So E to M to X is going to look like that. I curved it a little bit at the end just to make it work, but we're trying to prove that that is the same straight line. Now, proving vectors are on the same straight line and proving that they're parallel is really, really important. This is what these big questions are really made up of, these type of questions. So very often we are asked to define certain things that we take for granted, such as a straight line. One of my favorite definitions in maths is the definition of a straight line. Now, we all know what a straight line is. Just by looking, we can tell if something is a straight line. But there is an actual definition for it. There has to be, because maths is all about definitions and all about proof. Something doesn't exist unless we can prove it can never be wrong. And a straight line, to exist, has to have a definition. The definition of a straight line, quite simply and beautifully, is the shortest distance between 2 points. That's it. If we have this point and this point, a straight line is the shortest distance between them. I think that's amazing. You can go tell your friends. You'll be the most popular person at the party. To prove that vectors are on the same straight line, what you have to do is find 2 of the vectors that lie on the line. So from E to M to X, we have the vector EM, we have the vector EX, and we have the vector MX. Just remember, a vector is just a length, a line with magnitude and direction. So from this point to that point on this diagram is a vector. We have to prove that two of those vectors are parallel and also go through the same point. Because if you have two lines that are parallel to each other, i.e. going in the exact same direction, and they go through the same point, they must be one straight line. So that's how we do it. The way to do it for us now is just to find two of those vectors. So like I said, whenever the question is mentioning a vector, just find it. It's talking about e to m to x. Let's find e to m. Let's find e to x. We could also find m to x, but we actually only need to find two of the three. So we'll just pick the easiest ones. E to m is probably going to be the easiest one because that's not extended beyond the diagram. So let's find em. So I'm going to say, now I can see that this line here, that vector there is b. And because it's a regular hexagon, that means there to there is also going to be the vector b. Because it's the exact same length and it's the exact same direction. So from e to b is 2b. And then from b to m, well, that's half of b to c, which is exactly the same as a to o. So it's going to be minus a half a. Because we're going backwards, the direction against the arrow, and only halfway of the line. So that's the vector em. Now let's find, let me try and remove some of the lines here just to make our life a little bit easier. Let's remove that and that. Let's find mx, just because we can just keep it all up here. So mx, how do we do that? So m to b, then b to x. So m to b is going to be quite straightforward because that's just half a. We should be able to spot that that goes, again, that mb lies on cb, which is the same as oa. But now how do we get from b to x? And this is the toughest part of the whole thing. From b to x. All we know about bx is it's the same direction as ab, but it is got a sort of length of 2 compared to a length of 3. Now, AB, to get from A to B, that is going to be minus A plus B. So AB, let's write this down, equals minus A plus B. BX, if AB is worth 3, BX is worth 2. That's what we were told in the ratio. That's what we've written up here. Which means BX is going to be 2/3 of the size of AB. That is the key part to this question. So BX is, I shouldn't have written it like that. Actually, well, we'll keep BX, and then this will just be like an aside. So this is going to equal half A plus 2/3 of AB. Now that means it's going to end up being, so let's write mx again down here. Half A plus 2/3, and then we're going to plug in what AB actually is, of minus A plus B. And then we're going to multiply it all out, simplify it, collect like terms. Mx equals half A minus 2/3 A plus 2/3 B. Half take away 2/3 is going to be negative 1/6. So it's going to be 2/3 B minus 1/6 A. And what do we got to do next? Prove that E, M, X are on the same straight line. Okay, so we got EM up there, 2B minus half A. And we got MX down here, 2/3 B minus 1/6 A. To prove those are parallel, we have to prove that the vectors are multiples of each other. So if two vectors are multiples of each other, the way we write it is we factorize the vectors, and they should have whatever's, and they should basically have a bracket that's exactly the same, and then a multiple outside them. So It's pretty tricky to do with these ones. These aren't nice ones. But let's write this one up here. So if we factorize out a half, that's going to give us 4b minus a. Because if we times the half back into 4b, that creates the 2b. If we times the half to the minus a, that creates a minus half a. And this one, I'm going to take out a sixth. That's a sixth. And then because 2/3 is 4/6, that's going to leave us with the 4b minus a. And because 4b minus a and 4b minus a are here, this one up here is just a half of it. This one down here is a sixth of it. That shows they are parallel. They are multiples of each other, so they are going in the same direction. And because em and mx both go through point M, by definition, e to m and m to x both go through point M, they are parallel, going through the same point, so they are the same straight line. Okay, we've got a comment here saying you don't get the half a stuff. I assume that means with up here we had the mx, and we were talking about half a. So I'm going to try and clear some of this stuff up here so I can explain in a little bit more detail what I mean by that. So as we can see on the original diagram, the vector a is O to A. So that is A. Because CB is the exact same length and direction, that is also considered vector A. Because we want to go from M to B, we want to go halfway along. That's why it's half A, because we're literally taking half the line. Turn to the next question. How is it 2/3 and not 2/5? Well, really important question. I'm really glad you asked, actually. So it's 2/5 of the entire line. You're quite right. Because, let me just try and erase this, and I will draw that back on. This part was worth 3, and this part was worth 2. To point X out here. 3 and 2. Now, if you're taking the entire line as a whole, A to X, then yeah, BX is 2/5 of the whole thing. That's absolutely correct. But we're not doing that. What we're doing is we know that AB, this section here, is minus A plus B. We want to know what the section next to it is. So we're not looking for 2/5 of the whole thing. We're completely splitting up this section from what's next to it. Now, this bit is worth 3. This bit is worth 2. So it is quite literally 2/3 of that. If I can maybe do it in slightly more pictorial form, this is split into 3 parts like that. So we got 1, 2, 3 parts. This one is only split into 2 parts, 1 and 2. So from A to B, which has 3 parts, if you take 2/3 of A, you get the 2 parts, which is represented on B to X. It is a really complex section, and it's a horrible question. It kind of is one of those where if this ended up in your exam, you'd be extremely unlucky, but we have to cover all bases regardless. What's more important, what the most important thing about this is this definition down here. Prove they're on the same straight line. If things are on the same straight line, if 2 vectors are on the same straight line, they are multiples of each other, meaning they're parallel, and they go through the same point. 2 parallel lines that go through the same point are one straight line. So we'll move on, but if you don't understand it 100%, please don't worry about it. Most people won't. But if you know it just enough to get a few marks, trust me, that's going to be better than most. And it will set you above everyone else, almost. So this one is a similar idea, but actually probably going to be a little bit easier because we don't have points extending beyond the diagram. We have points extending beyond the triangle, but they're included in the diagram. So that's much more helpful. So let's take a look at it. O to A is 5A, O to B is 3B. C is the point such that, oh God, all right, it does look like it's going to be a point extended. Oh no, it's okay. C is the point such that OC to CA is 4:1. So C is going to be between O and A because, well, we can see OC, then C to A. And it's going to be 4/5 of the way along. So really important we try and understand that. O to C is 4 parts, C to A is 1 part. So it's going to be probably around about here. So that's going to be point C. And that'll be 4/5. And it's going to be 1/5. And what's quite nice is the length of O to A is 5. So splitting that up into fifths is going to be so easy. So O to C is just going to be 4A because it's 4/5 of 5. And C to A is just going to be A because it's 1/5 of 5. So that's going to be very, very nice. M is the midpoint of AB. We can see that. Midpoint's always great because you just half whatever vector you're trying to find. D is the point such that so the OB to OD is 3 to 4. Now, this is another really interesting one. O to B is 3 and O to D is 4. Now, the reason why that's quite nice is because O to B is 3B, which means O to D will be 4B because it is literally 3 to 4, which means this B to D section must be the extra 1B. Now, all of this information, it's almost cryptic in the way it's given to us. Believe me, it's not easy to find. But if you can find it, it's really, really valuable. Just to clarify, this topic is for the grade 8 and 9 marks. So I'd say 80 to 85% of people won't get any of these marks. So it's really important just to think you're not necessarily trying to answer the question. You're just trying to get the first mark that might lead to the second mark, etc. Show that CMD are on the same straight line. So remember, to prove that points are on the same straight line, we're just going to start by finding the vectors that lie on the line. So let's find CM and CD. So we'll start with CD, because that's going to be quite simple. That's just going to be minus 4/5 of 5A, because we're going against the arrow, so it's going to be negative, and we want 4/5 of the whole line. And then we're going to do plus 4B to get all the way to D, which is going to give us minus 4A plus 4B. Quite nice. And now let's do CM. So CM will go up to CA, which is going to be 1A. And then down to AM. And remember, AM here is half of AB. So instead of adding AM, we're going to add half of AB. And AB, we go minus A, so we go from A to O, then O to B, which is going to be minus 5A plus 3B. Then we're going to expand that bracket and collect like terms. So A minus 5 over 2A plus 3 over 2B. And minus 5 over 2A is going to give us negative 3 over 2A plus 3 over 2B. I'm skipping through these sort of fraction questions quite quickly because, well, we want to focus on the vectors. But if you are struggling with the fraction sums that I'm doing, that's just a little warning to you to maybe go back and practice that. But if you do IGCSE, both your exams are calculator papers, so you'll be fine. You can just type that shit into a calculator. So what have we got here? Well, what's already looking good is that C to D is minus 4A plus 4B, and C to M is minus 3 over 2A plus 3 over 2B, in the fact that the numbers are the same. So that's a good sign. So let's factorize them. So let's take 4 out of this one, simply because we can. We're going to be left with minus A plus B. And if we take 3 over 2 out of this one, we're going to be left with minus A plus B. So once again, what we've proven is that these two vectors are multiples of each other. CD is 4 lots of minus A plus B, and CM is 3 over 2 lots of minus A plus B. So they're different sizes, they're different lengths, but the vector direction they're going in is the same. So we've proven that they're parallel. Now, how do we prove they're a straight line? By showing that they go through the same point. And the fact that CD is literally C to D and CM is C to M, they're both going through point C. So because these vectors are multiples of each other and both going through the same point, point C, that is proof they're the same straight line. Okay, how many more vectors questions do we have? We've got a couple more before we move on to our next topic. I'm also aware we're probably going to have a break within the next 5 minutes. So probably best not to start a new topic before the break. We'll maybe do one more of these questions and then take a break and come back with something new. So should we do the parallelogram one or try? I think we haven't done a parallelogram one before. So let's do this one. The great thing, sorry, sticking to that last one, Song Kim, how do you write that out as an answer? Very good question. It's actually going to be just literally writing a bit of a sentence. So just actually stating the words I said, which were vectors CD and CM are multiples of each other. And that will be shown basically based on the working you've done. And both go through the point C, therefore proving it is a straight line. So generally when we have answers that require explanation, my advice is as long as you're showing that you know what it means, the examiner will accept it. There's no way you can know exactly the keywords the examiners are looking for, but if the examiner's looking at this and thinking, this person knows what they're talking about, then you're going to get the tick. So these vectors are multiples of each other and both go through the point C, therefore they are the same straight line. They are on the same straight line. That's how you do it. The great thing about parallelograms is that, well, they're opposite lengths of parallel. That's so good for vectors because vectors are all about direction and length. On a parallelogram, this line here, OA, is exactly the same as BC. It is the same length, it is the same direction, because by definition, it's a parallelogram. They are parallel. So we are told that OA is 2A. That means BC is 2A as well. We're told O to B is 2B. That means AC is 2B as well. So that's already uncovering a lot of helpful information. I'm going to delete these now because we're going to need to actually be able to look at the page. And I've written over some stuff. D is the point at OC such that OD to DC is 2 to 1, meaning this length has a value of 2 and this has a value of 1. So we would say this part is 2/3 of the line and this part is 1/3 of the line. E is the midpoint of BC. We love midpoints because it just splits the line exactly in half. And that's just a lot easier to deal with. Show that ADE are on the same straight line. A to D to E on the same straight line. So as we know, we're just going to find two of those vectors. Probably A to E is going to be really, really simple. And then maybe A to D as well. We'll do that one. So let's start with A to E. AE is, let's go along here and then down there. So that's going to be 2B plus, then C to E. Remember, this side, C to E, is exactly the same as that one there. And it's halfway. So it's going to be actually minus A. Just minus 1A. Because the whole length is going to be 2A and we're only going half of the way down. So AE is 2B minus A. Now, what did I say the other one? AD. Okay, so AD is, so let's first of all choose the journey that we're going to do from A to D. I think we should go A to C and then C to D. So AC, nice and easy, is going to be 2B as well. And then C to D. Now, we cannot go along that line, C to D, because it doesn't have an arrow on it. Remember that. So what we're going to do is we're going to find the entire line that it's on. So instead of CD, we're going to find CO, the whole vector of that line. So C to O, let me see if I can change the color here. So C to O, we're going to go there, then there, which is going to be minus 2A minus 2B. And how much of that do we want? We want 1/3 of CO. So that's going to be 2B plus 1/3 of minus 2A minus 2B. Then we just expand and simplify. 2B minus 2/3 A minus 2/3 B. Then collect like terms. So the 2B take away the 2/3 B is going to give us 4/3 B. 4/3 B minus 2/3 A. So that is a simplified vector. We now need to prove what it's asking us. Prove they're on the same straight line. So we're just going to factorize both of them. Well, we kind of don't need to factorize the AE one up here, 2B plus A. That's fully factorized. We can't really take anything out. So we'll leave that as it is. And instead, we'll factorize out this one down here. So let's take out 2/3. If we take out 2/3, what we'll be left with is 2B minus A, which is exactly the same as what we had up here. The 2B minus A and 2/3 of 2B minus A, meaning they're the exact same direction, just one is got a length of 1 and the other one's got 2/3 of that value. So we've proved that they're parallel because they're both multiples of the same vector. And simply because they both go through point A, AE and AD, they go through the same point. So once again, to sum up, how do we answer this question? A, D, and E are on the same straight line because they are multiples of the vector 2B minus A, because AE and AD are multiples of the vector 2B minus A, and both go through point A. Okay, we are going to take a break, just a very short break, maybe just over 5 minutes. We'll have a timer on the screen for you so you can know exactly when we're going to come back. But go stretch your legs, get the blood flowing, get the blood pumping, have a glass of water, and then we can come back and be fresh and ready to go. I'll see you in a few. Welcome back. Welcome back, everyone. I hope you stretched your legs, got a glass of water, and are feeling refreshed and replenished. I certainly am. A little sip of coffee, a little sip of water, balance it out, stretch my legs a little bit, and I'm ready for some similar shapes. So we're going to start off with some 2D similar shapes because these are the quite simple ones that will sort of help build us up to the 3D shapes. We are going to probably need our calculator for this. So if you have a calculator on standby, I'd grab it. Or if you have it in your bag or downstairs or something, run and get it. We're going to be dealing with some scale factors in this topic. For those who don't know what a scale factor is, it's basically a value that you use to multiply to figure out what the equivalent is on a bigger version of something. So if I've got, I don't know, I can't really think of example. This pen, and I got a bigger pen. It's the exact same shape, but it's larger, 2 times larger. That would have a scale factor of 2. So the length would just be 2 times longer. I don't know if that was a good example or not, but right here we've got some questions where it's going to be the perfect examples. So we'll just jump straight into them. We'll start with question 1. So here we've got 2 triangles that are sort of meeting right there, almost creating some awkward kite shape. Or bow tie shape rather. We are told AB is parallel to XY. So AB is parallel to XY there. The lines AY and BC and BX intersect the point P. So that's all happening. This is basically just describing what is already happening on the diagram. So make sure you read all the information, but don't worry about it too much, especially if it's just describing to you what you can already see. The question is asking us to work out the length of BP. The first thing we need to spot here is that this is a similar shapes question. The way we figure that out is, well, through practice, by doing enough of these questions to notice it, to be perfectly honest. But we can see that there are 2 triangles, and yeah, actually with this one, it's not as clear that it's similar shapes other than the fact that I'm telling you. Later on, we'll be able to get to it. You'll see other questions make it much clearer. But let's crack on with it anyway. When we realize we have 2 similar shapes next to each other, we need to figure out the scale factor between them, i.e., what do we times one by to get the other? To do that, we need to figure out which are the similar lengths. In this particular case, they've highlighted to us that AB and XY are parallel to each other. So those are going to be the similar lengths to each other. We also have BP is the similar length to PX. And using all of the colors, AP is the similar length to PY. Now the scale factor in this case is going to be what do we times 6 by to get 15. To do that, we do 15 divided by 6, or we can do 6 divided by 15. Either way, the scale factor can be above 1 or below 1, depending on if we're timesing or dividing. So in this case, the scale factor will be 2.5 because we times 6 by 2.5 to get 15, and we divide 15 by 2.5 to get 6. That is the value that connects these two shapes, or the lengths of these two shapes. Which means if we have one of the lengths on one shape, we can times or divide by 2.5 to find the length on the other shape. I've got a lot written here, so I'm going to delete pretty much all of it except for the scale factor so we can start answering this question. That's pretty efficient rubbing out there. I'm pretty pleased with myself. Scale factor is 2.5. We know that px is 12.5 and we're looking for bp. Now bp is on the smaller shape. Px is on the bigger shape, meaning the scale we're going to have to divide by 2.5 to find the length of bp. So quite simply, it's just going to be 12.5 divided by 2.5. And we can type that into a calculator and it's going to give us an answer, well, of 5. So this length here is 5 centimeters. So the key thing about these questions, about similar shapes questions, is find the lengths that are similar to each other. The next questions will be very clear as well, but just because this is the first one we've done. Find the lengths that are similar, find the scale factor between them, and then that is going to be the value we multiply or divide by to find the equivalent length. Now, this is a more typical type of question that we'll find, but it's a shape inside another shape, and that's what makes this tricky. We have one triangle inside another triangle. So my first bit of advice is draw these two triangles out next to each other. So let's draw out the smaller triangle first. Let's draw it here. So the smaller triangle is going to look like this, and the bigger triangle is going to be the whole thing that looks like this. So we've got B, A, E, and this is A, C, D. So hopefully you can tell that this ABE is just this section for that one, and ADC is the whole thing, represents that one. And now let's input the lengths. So this is 9, this is 6. We don't know the base one there. A to C, well, it's the entire length there, so it's 12. And the base here, oops, so that's 12. And the base here, C to D, is 7. And we don't know what A to D is. We know what A to E is. We know part of it, but we don't know A to D, so we leave it. Question is now asking us find the length of ED. Well, actually, before we find the length of ED, let's find the scale factor. Now, we should be able to see through these two shapes that length, I'll do it in a different color as well. I'm going to get used to this switching up colors. I think it's a good thing to do. That length AB and AC are the two similar shapes here that we know. Now, that and that are similar shapes, that and that are similar shapes as well, but we don't know the pairs of them. So we're going to stick with AB and AC as 9 to 12. So we can do 9 divided by 12, which is 3 over 4, 3 quarters, 0.75. So our scale factor is 3 quarters, because those two lengths that are the same, sort of, not the same length because they're different lengths, but the same side, the equivalent sides, that's the way of putting it. Those two sides are the equivalent sides. We divide them to figure out which one, to figure out the scale factor, 3 quarters. That is what we're going to be timesing and dividing by. Now, this question is being a bit mean because it's asking us to find ED. Now, ED is just this section of a line here. It's not actually on any of the shapes that we have drawn. So my advice is actually ignore what they're asking us. Let's just find all of the lengths on our diagrams, and then we can answer their questions afterwards. So we know AE is 6. So we are going to use 3 quarters to get what AD is. Now, if we did 6 times 3 quarters, we're going to get 4.5. Now, that doesn't make any sense because this one is on the bigger shape. It can't get smaller. So we're going to have to divide by the scale factor. So always keep your eyes open for that eventuality. Remember, scale factor is not always what we times by, sometimes what we divide by. So we're going to do 6 divided by 3 quarters, which is 8. That makes a lot more sense. Now, with these ones down here, so this one is 7. So we want to find the equivalent length, which is that. And this time we are going to do 7 times 3 quarters because that's going to make it smaller, 5.25. Calculate the length of ED. So ED is this section down here, but what we now know is that the entire length is 8. This length is 6, meaning there to there must be 2. So that's a nice easy answer. And then calculate the length of BE. Well, we've just done that. We've already done that, so that's brilliant. 5.25, just based on the fact that 7 is the equivalent length, times it by 3/4, and you get 5.25. Here's another example where it's a triangle inside another triangle. So remember, the first thing we're going to do is draw these triangles out next to each other, because then we can actually see the individual lengths and we'll be able to see so clearly what the equivalent lengths are. So let's draw this here. So the small one coming first. We've got A, B, E. This is 4.8, and we know everything about this triangle, so this is very helpful. And 4. And then the larger one, which is A, C, D. What do we know about this one? We know the entire length of AC is 10. We actually don't know anything else. Again, we know sort of part of this is 4.8, but because we don't know the whole thing, that's not very helpful to us. But straight away, we spotted the equivalent length, or we should have spotted the equivalent lengths. There's going to be AB and AC, 4 to 10. So let's do 10 divided by 4, which is 2.5. If you did 4 divided by 10 as well, that also works. If we do 4 divided by 10, we get 0.4. Once again, it's just either timesing or dividing by 0.4 or 2.5. You just have to be sensible about whether you're timesing or dividing them. So let's take 2.5 as a scale factor, because that's the one I said first. So 2.5 is a scale factor, which means if we have a small length and we're trying to get to the bigger one, we're going to times by 2.5. And if we have a length on the big shape and we're trying to get to the small one, we're going to divide by 2.5. Calculate the length of CD. So that's this base length here. I've just noticed the very Christmassy colours I'm using, red and green. So I hope you're feeling very festive this festive season. I certainly am with these similar shapes. So the smaller shape equivalent length is a length of 5. So we're going to do 5 times 2.5, which gives us 12.5 as the length of CD. And in just a beautifully coincidental way, 12.5 not only is right where CD is, but it's also on the answer line where CD should be. Don't you just love it when things work out? Calculate the length of ED. Now, once again, they're being a bit mean here because ED is just part of this line. But remember, what we do with these types of things is we just find all of the lengths on our diagrams, and then hopefully it's not too difficult to find the questions they're asking for. So let's just find the length of AD. Now remember, our scale factor is 2.5. The equivalent length on the smaller shape is 4.8. So we're just going to simply do 4.8 times 2.5, which gives us 12. So that length there is 12. Then we can kind of go back to our original shape up here. We know the whole thing is 12. We know this part of it is 4.8. So if we do 12, take away 4.8, we are left with 7.2, which is going to be the answer for just this ED section right there. Now this is much nicer. Two shapes already drawn out next to each other. Makes our life a lot easier. So let's see if I'll give you a few seconds to just take a look at this. Can you figure out the scale factor or how to work out the scale factor? Are there two equivalent lengths on there that you know the lengths of? The answer is yeah. It's the base length there. So this AB, which is 8, and this PQ, which is 12. Now the next step, do you remember how to work out the scale factor? I hope so. We just divide them. And again, it doesn't matter which way you divide them. You could do 8 divided by 12. You could do 12 divided by 8. As long as you understand when to times or divide the scale factor, whether you're getting bigger or smaller. Let's do 8 over 12, because that's going to give us a nicer fraction, I think. Actually, they're both quite nice fractions. Let's do 12 over 8. Yeah, I've changed my mind. We're going to do 12 over 8. So 12 divided by 8 is 3 over 2. So our scale factor is 3 over 2. That says SF for scale factor. Which means we're going to be timesing and dividing by 3 over 2. to get to the equivalent length. Calculate the length of PR, that is this one here. The equivalent length is 26 on this shape, so we're going to be timesing by 26, which should give us 39. And find the length of BC. Well, obviously, that's that one there. The equivalent length is 45, so we're going to be dividing by 3 over 2. 45 divided by 3 over 2 is 30. A nice round number for us there. So that was actually a lot easier than the previous ones. We probably should have done that one first, but never mind. This one, once again, is like our original one. Now, hopefully, after we've done sort of 3 or 4 of these questions, you start to spot similar shapes quite easily. Question is, with this one, can you figure out what the equivalent lengths are? Now, the easy ones are always these ones here. DE is equivalent to AB, meaning we can get our scale factor from the 6 and the 9. With the other ones, we have to be really, really careful. This one is equivalent to that one there. And this one is equivalent to that one there. It's kind of got that sort of twist and flip relationship between these two triangles. Okay, so how do we figure out our scale factor? 6 divided by 9 or 9 divided by 6, it does not matter which way you do it. Let's say 9 over 6. 9 over 6, which, if you just simplify that fraction, is 3 over 2, 1.5, whatever you want to write it as. But that's our scale factor, 3 over 2. Calculate the length of CE. So CE is obviously that one in blue that I've done. Its equivalent is AC, which is 8 centimeters. Now, let's see what happens if we do the scale factor the wrong way around. If we do 8 divided by 3 over 2, we get 5.3 recurring. Now, not only is that not a particularly nice number, it's smaller than 8. So we just need to keep our eyes open for when we might have used a scale factor incorrectly by dividing it when we should have times it. Doesn't make sense that we get to a bigger shape, but the equivalent length is smaller. So we go back to our answer, or rather our working out on the calculator. Instead of dividing by 3 over 2, we times by 3 over 2. Get a much nicer answer of 12. Next, calculate the length of BC. So BC is on the smaller shape, so we're going to be expecting an answer smaller than 13.5. So let's do 13.5 divided by 3 over 2, and we get 9. Beautiful. That's what we love to see. This is a similar shape. Again, we can see it's a triangle inside a triangle, but they're asking it in a slightly different way. They're giving us a ratio again here. Now, I don't know about you, but ratios seem to come up a lot, I've noticed. So it's really, really important we're solid with them. Let's really try and understand what they're saying here. A to B, or AB to AC is 1 to 3. So AB is this. AC is the whole thing. And that relationship is 1 to 3. So we know AB, we're being told, is 5 centimeters. So if that's worth 1, if 5 centimeters is equivalent to 1 part, 3 parts is going to be 15 centimeters, meaning the entire thing is 15 centimeters. So it's not AB to BC, it's AB to AC, 5 to 15, because it's 1 to 3. Calculate the length of CD. Well, if we draw these two triangles next to each other, we've got the smaller one, which is 5, 4, and we've got the bigger one, which we now know is 15, then CD here, we can see the scale factor there is 3, quite a nice one. So CD is going to be 12, because it's 4 times 3. Calculate the length of BC. Well, I've drawn a lot on this paper, so I'm going to just delete some of it so we can get a better idea of what it's actually showing us. Find the length of BC. Well, if we know the entire thing is 15 and this section is 5, then that must mean this bit is 10, which is relatively easy once we draw our diagram. And it just shows the power of drawing diagrams, how important they can be. This one is actually a completely different type of similar shape, but definitely worth doing. This again is the type of question where if it came up, you'd be very unfortunate because there's very few questions that are like this. Majority of them are like the ones we've been doing. But again, we need to be able to cover all bases to be able to give ourselves the best chance of getting as many marks as possible. A 20 euro note is a rectangle, 133 millimeters long and 72 millimeters wide. Okay, let's put that on the diagram. Just because notating a diagram, it's never done anything bad for us. So 133 here and 72 there. A 500 euro note is a rectangle, 160 millimeters and 82 wide. Show that the two rectangles are not mathematically similar. Interesting. We've been dealing with similar shapes previously. Now we're actually trying to prove that this one is not a similar shape. These two shapes are not similar to each other. What's interesting about that is when similar shapes exist, there is a scale factor. That's been the one thing that's been in every single question here. We find the scale factor between all of the shapes, and that accounts for all of the lengths. If they're not similar, they won't have a scale factor that applies to all of the lengths. So let's find a scale factor of 133 to 160, because those two, after all, are the equivalent lengths. So 160 divided by 133 gives us a pretty horrible decimal. So apparently scale factor at the moment is 1.203, and it goes on for a long, long time. And not only is that not a nice number, or rather the fact that it's not a nice number should give us some warning signals. But at the end of the day, if that scale factor works for these two lengths, then it works and they're similar shapes. So let's work out the scale factor of 72 and 82. I hope I didn't draw those lines and they look like ones now. So 82 divided by 72, the same way we did big divided by small in the last one, we'll do big divided by small here. 82 divided by 72 is 1.138 recurring. Now, just the fact that those two scale factors, length to length and width to width, are not the same proves that these are not similar shapes. The alternate way of doing it would be to take the scale factor we found for the lengths going across and apply it to the 72 or the 82. So if we're taking the 1.203, if we did 72 times 1.203, we would get 86.6, which obviously is not 82, meaning that if we used the scale factor for these lengths, it does not work for the widths, so they are not similar. Okay, now to some 3D shapes. So I've developed my own method for doing 3D similar shapes. I'm very proud of it, and I'm going to share it with you here today. It's what I like to call the LAV method. LAV in this case standing for length, area, volume. And much like we were finding the scale factors in the previous questions, we are also finding the scale factors here, but not just for length, also area and volume. Then we're deciding which one of those scale factors is going to be relevant for the question. So the question is always going to give us either a length, an area, or a volume scale factor just straight away. We can see from these two shapes, the two solid shapes are mathematically similar, so they're clarifying that for us, which is very kind of them. The base of shape A is a circle with radius 4. The base of shape B is a circle with radius 8. The surface area of shape A is 80. So they're telling us the two radii is the plural of radius, two radii on each of the shape. Now, is a radius a length, an area, or a volume? Well, radius is the length of the circumference to the center. It is a length. So because we know a length of the small shape and a length of the big shape, we can use those to find the scale factor of the lengths. And we do it the exact same way we did before, by just figuring out what we times one of them by to get the other one. And quite simply, this is 2. We times by 2. So hopefully that all makes sense so far. The scale factor of lengths is 2 because, well, these are two lengths and it's 4 to 8. Now, here's where it gets really, really interesting. I don't care about answering these questions yet. I want to find my LAV scale factors. We measure length in centimeters. We measure area in centimeters squared, and we measure volume in centimeters cubed. Now, the scale factors follow that same pattern. If the length scale factor is 2, the area scale factor will be 2 squared, so 4. And the volume scale factor will be 2 cubed. So 8. So really, really simple. Once we know the length scale factor, just square it to find the area scale factor, or cube it to find the volume scale factor. Or do both, which is the best thing to do. Now we've found these scale factors, we can actually start answering the question. And answering the question becomes so easy at this point. We just decide which scale factor we want to use. Work out the surface area of shape B. The surface area of shape B. Which scale factor do you think we're going to use to work out the surface area? The length, the area, or the volume? Obviously, they're talking about surface area, so we're going to use the area. Literally, the word is a giveaway. So we are going to, for this question, use the scale factor of 4 because they have said find the surface area. We're told the surface area of shape A is 80. A is the smaller one, which means the big one is going to have a bigger surface area. So we quite simply do 80 times 4. The surface area times the scale factor, which is going to give us a surface area now of 320 centimeters squared. And you can see they have the centimeter squared all drawn for us. So you don't need to worry about the units, but they're kind of giving us a clue there. They're saying, remember, area is centimeter squared. Next up, we've got, we're told the volume of shape B. The volume of shape B is 600. Work out the volume of shape A. I wonder which scale factor we're going to be using for this one. Obviously volume. Trying to create some suspense there, but I think you guys already knew it. Going to be using a scale factor of 8 because we've already found it because it was 2 cubed. So the volume of shape B is 600. We want to find A, which is the smaller one, so we're going to be dividing by 8. 600 divided by 8, I'm pretty sure is 75. And it is. Always good to check with the calculator, especially when you're doing a live session. You don't want to embarrass yourself. So 600 divided by 8 equals 75 centimeters cubed. That's it. So to recap, we find what scale factor they are telling us in the question. They're always going to tell us one, length, area, or volume. Figure out that scale factor by dividing. Then square, if it is the length scale factor, square it to find the area or cube it to find the volume. Once you found LAV, then you can start answering the questions. Let's move on to the next one. Two cylinders A and B are mathematically similar. The height of cylinder B is twice the height of cylinder A. The height of cylinder B is twice the height of cylinder A. Height, in terms of measuring height, is a length, and it's twice the height. So we should be able to figure out what they're saying in that sentence is that the scale factor of lengths is 2. You say LAV. L is 2, which means the area scale factor is, say it to yourself, that's right, 4. And the volume scale factor is what? That's what I'm talking about, 8, 2 cubed. So those are our scale factors. Now that we've got them, we can start actually answering the question. The total surface area of cylinder A is 180. Calculate the total surface area of cylinder B. I'm asking for surface area. Are we going to be using L, length, A, area, or V, volume? Quite obviously, because they're talking about surface area, they're mentioning it, not us. They're saying surface area. We're going to use A. Scale factor of A is 4. So we want to go from small to big. They're telling us A. We want to find the bigger one in B. So it's going to be 180 times 4, which is 180 times 4, 720. 720 is the surface area of cylinder B. So as you find with a lot of these topics, the maths involved is actually quite simple. It's just the knowing, it's the background of it, the method behind it is what's difficult. And actually, even then, knowing it is hard enough, then you've got to remember it. And that comes down to you. I can tell you it, no problem. But you've got to do the practice to try and remember it. This is a horrible question. We're not going to do that one. Maybe we'll come back to that one if we have time. But let's focus on this one instead. A couple more cylinders. Cylinder A and cylinder B are mathematically similar cylinders. The length of cylinder A is 4. The length of cylinder B is 6. So they're making it very clear that they're talking about lengths here. So we're dealing with length scale factor of 4 to 6. So you can do 4 divided by 6 or 6 divided by 4, whichever way you want to do it. But we can figure out in terms of LAV, the scale factor is 1.5. 6 divided by 4 is 1.5. So the area scale factor is going to be 1.5 squared, which is 2.25. And the volume scale factor is going to be 1.5 cubed. Don't do 2.25 cubed. That's a mistake a lot of people make. They square it and then the area, they then cube that. No. We go back to length. Length is what we cube to find volume. And that is going to be 3.375. So now we have our LAV scale factors. We just need to decide which ones we're going to use. The volume of cylinder A is 80. Calculate the volume of cylinder B. Once again, it can't be clearer. We're dealing with volumes. So we're going to use our V scale factor here. And we're going to just do 80 times by 3.375. 80 times 3.375 equals 270. So the volume of cylinder B is 270. Now, yes, okay. This is where it gets slightly more complex in how it's done, because we're not given a length scale factor this time. So it's really important that we practice these ever like slight changes they throw in, because if it's one thing knowing how to do it the same way every time, but let's face it, in an exam they're not going to give us something exactly the way we want it. They're going to throw some sort of curveball in there to see, not do you know how to answer this question step by step, but do you understand the topic? That's what they're testing. So here, we'll use the same structure, but we have to be a little bit flexible within that structure. X and Y are two geometrically similar solid shapes. So they're not actually telling us what shapes they are. All they're telling us is that they are similar shapes. The total surface area of shape X is 450. The total surface area of shape Y is 800. So they're giving us both areas in this one. So we have to jump straight to find the area ratio. So let's do 800 divided by 450, which gives us, well, a horrible decimal, if I'm being honest. So let's actually keep this one as a fraction, because the fraction looks quite nice. 16 over 9. Now remember, this is the area scale factor because the question has mentioned, it has said the surface area of shape X, the surface area of shape Y. The question is talking about area, so we are looking at this as the area scale factor. Now, previously, if we knew the length scale factor, we would square it to find the area scale factor. So if we know the area scale factor, what do we do to find the length scale factor? We square root it. And nicely enough, both of these numbers, 16 and 9, are square numbers. So square rooting them is really easy. It's just going to be 4 over 3. And then volume, well, remember, we cube the length scale factor, not the area. So we do 4 over 3, and we're going to cube that, which gives us to 64 over 27. So now we have all three of our scale factors. Hopefully that made sense. So remember, just to recap, just in case it didn't, the question is giving us the two surface areas, so we can figure out the area ratio or scale factor between them by dividing. Square root the area to get the length, and then cube the length to get the volume scale factor. Then it's saying the volume of shape X is 1350. Calculate the volume of shape Y. So let's just clarify, which shape is going to be bigger here, X or Y? They're saying here, surface area of X is 450, surface area of Y is 800. So Y is the bigger one. So our answer has to be bigger than 1350. So we are going to be doing 1350 times 64 over 27, which is a very nice number, 3200. If you don't get a nice number for any of these types of questions, any question whatsoever, doesn't mean it's wrong, but it does mean maybe have a look at it again. But when we get a really nice number like this, we can have provided we know what we've done so far, we're feeling confident on it, we can have a lot of confidence that answer is indeed correct. Okay, we've only got a minute or so, a few minutes left, so let's try and squeeze in one more question before we go on our merry way. This is going to be some of the last maths I do in 2023. It's quite incredible. So let's make it a good one. 5 marks in total for this part A and B here. So let's work through this one together. Two cylinders P and Q are mathematically similar. Total surface area of cylinder P is 90 pi. Don't get thrown by the pi. They love throwing little curveballs in there, but that pi doesn't change anything. The total surface area of cylinder Q is 810 pi. The length of cylinder P is 4. Okay, so they've told us the two areas, or the surface areas, but we're just going to look at it in terms of area. The two areas, 90 pi, 810 pi. So we find the area scale factor by dividing. So 810 pi divided by 90 pi. When you put that into your calculator, the pi's just naturally cancel each other out. So it's 810 divided by 90, which means the area scale factor is 9. And we can see that quite clearly. 90 pi times 9 gives you 810. So it always makes sense. Okay. What's going on with this pen? Don't fail me now. Oh, we went through the whole lesson without crashing, just to crash a minute before the end. Though I will reload it and we're back on track. Bear with me. Here we are. Back with a vengeance to finish off 2023. Oh, and it's working smoother than ever. Don't you just love that? So if we have the area scale factor of 9, how do we find the length? Think about it again. Think about it again. Square root. So the length scale factor is going to be 3. Then we cube that to find the volume scale factor, which is going to be 27. Then once again, for both of these questions, A and B, it's just a case of which one do we choose? Choose the correct one, and it's such simple maths. The length of cylinder P is 4 centimeters, so that's the smaller one. Work out the length of cylinder Q. Length, quite literally, they are saying it. Length scale factor is 3, so we times by 3 to get an answer of 12. The next one, the volume of cylinder P is 100 pi. Work out the volume of cylinder Q, give your answer as a multiple of pi. When it says give your answer as a multiple of pi or in terms of pi, it just means something pi. So we're going to use the volume scale factor for this one. So we're going to be, again, going from small to big. So we're going to be timesing by 27. And 100 pi times 27 is just 2700 pi, which is the answer. All right, well, we'll finish there. Thank you so much for joining us. And for those who stuck through from beginning to end, thank you very much. I hope you learned a lot. And have a great new year. Join us next week. It won't be on a Saturday. I will say that. We're not 100% confirmed what day it's going to be. But if you keep an eye on my TikTok and the Examiners TikTok and Discord pages, you will be notified as to when, what time and what day the session will be. And we would love to see you there. So have a great new year, and we will see you very soon. Bye-bye.